So good afternoon, everyone. Welcome to the 2020 Better Buildings, Better Plants Summit Virtual Leadership Symposium. Thank you for being with us today, and I look forward to your participation in today's session. Next slide, please. So today's session is all about stumping the chumps. You'll get to meet the chumps here in a little bit. The conversation will be focused around how to optimize critical facilities. The session will be very interactive, and we look forward to addressing all your questions around critical facilities. Before we dive in, there are a few housekeeping items I'd like to cover. Please note that today's session will be recorded and archived on the Better Building Solution Center. We'll be able to follow up when today's recordings and slides are made available. We'll follow up with you. Attendees are in listen-only mode, meaning your microphones are muted. If you experience any audio or visual issues anytime throughout today's session, please send a message in your chat box in the window located below on your Zoom panel. All right. My name's Otto VanGeet. I'll be the moderator for today's session. I'm a principal engineer at the National Renewable Energy Lab, or NREL. I'm a registered mechanical engineer, and I lead our work at NREL on critical facilities like you'll be hearing about today. My co-moderator is Rachel Shepard from the U.S. Department of Energy's Federal Energy Management Program, FEMP. In today's session, she'll be behind the scenes fielding questions. Rachel leads FEMP's work on critical facilities. So next slide, please. So the agenda. We'll be going through introduction to critical facilities. Those facilities are data centers, labs, water, wastewater facilities, and the energy water nexus, hospitals, and then high security facilities and others. We'll be going through having the speakers do a brief 5-minute introduction on each critical facility type. After that, we'll be having the majority of the session be a panel discussion. The panel discussion will be broken into 2 rounds. Round 1, we'll have 3 each sessions at about 10 minutes per topic. Those topics will be continuity of operations, project implementation, and then energy management best practices. Round 2 will be the remaining questions from Slido, which I'll explain soon. You can also follow along on social media. Here's the social media on Twitter and LinkedIn and the address for that. So you can follow that. And then next slide, please. So Slido, logistics-wise, Slido will be used for the platform for our Q&A throughout the webinar. Please go to slido.com right now and see if that works for you. It's highly interactive, so using your device, please go to Better Buildings, the site there, and then you should be able to see a list that's provided. Scroll down the list and select Stump the Chumps this session. I'll give you a few seconds here to do that, and then we're going to go through and test our Slido. I just wanted to remind you that Slido is where we need to send the questions. We will not be answering any questions through Zoom. All right, so I think everybody's had a moment to load Slido, and the first question that you should be seeing is, where are you joining us from today? So please answer that question, and I'll get to see, we're starting to see all over the country. Maryland is the early winner. We got a lot of Chicago. Chicago's now the winner. Denver's good. That's where I'm based out of. We've got Philadelphia, Indiana, pretty much the whole country covered, which is great. It looks like the overall winner was probably Chicago and Maryland, and Chicago is looking like it's going to be the overall winner. So thank you for joining us from all over the country. So let's go. It's pretty good. We're also getting 147, 150 responses out of 350 or so participants. So pretty good responses. And again, good job in Chicago. You guys get the early win. Let's go ahead and we'll go to the next slide. So this is another Slido question. And this question is, what critical facilities do you work with the most? And it looks like, reading the results that hopefully you guys are seeing right now, laboratories are the winner, other, which could be all other categories. We've got kind of a third laboratories, a third other, a third data centers, and then some hospitals are doing good also. Emergency management centers, public safety. So kind of a good representation. And it looks like, yeah, it looks like other, which could be anything, is kind of the overall winner, with the labs is close second, data centers third, hospitals fourth, wastewater treatment plants in fifth, but a good representation and a good number of participants, about half the participants, 150. So that's great. That helps me as a moderator also to focus on different critical facilities types. So now we're going to go to introducing our panelists. And I'll provide more detailed introductions, and you'll get to hear from each of these panelists, but starting at the upper left-hand corner, my friend and colleague Dale Sartor from Lawrence Berkeley National Labs, then my friend and colleague Wendell Brase from University of California, Irvine, Jen Muir from JKMuir Limited, Daniel from New York-Presbyterian Hospital, Daniel Mastin, and then Chris Halpin from Energy Services. With that, from NV5 Energy Services. Sorry about that, Chris. Thanks to all of our panelists for being with us today. And they'll share their thoughts soon about critical facilities that they specialize in. But before turning it over to them, I'd like to first provide some brief information on critical facilities and why energy and resources are important to them. So this is a slide on what are critical facilities. And according to FEMA, the first bullet, critical facilities provide services and functions essential to an organization or community. And then from the Patriot Act, critical facilities house critical infrastructure, which collectively refers to those assets, systems, and networks that, if incapacitated, would have a substantial negative impact on national or regional security, economic operations, or public health and safety. And then there's some images along the bottom. The bottom left is a water or wastewater treatment, which we'll hear about. Image in the middle is a laboratory building, and the image on the right is a data center. So with that, let's go ahead and we'll go to the next slide. And we're going to talk about resource use a lot in this webinar, and the resource use in critical facilities is significant. That's because they're resource intensive facilities, and again, our panelists will describe how. So we're going to hear about the importance of optimizing these facilities. And what I mean by optimizing is being efficient with the resources, again, energy, water, et cetera, costs, and operations. So optimizing all three for these critical facilities. And then due to increasing threats such as natural disasters, we need to plan for continuity of operations for critical infrastructure. And the NOAA image on the bottom is a nice image where the vertical bars and the left-hand vertical axis show number of events, and then the lines and the costs in billions of dollars on the right-hand axis shows an increasing trend as time has gone on. And we're all aware of this with different hurricanes and storms and et cetera. And this breaks those down by different colors, but all of these things affect our critical facilities. So let's go ahead and we'll go to the next slide, please. So some common threads that you're going to hear from today's panelists about critical facilities. Again, that they're typically resource intensive, meaning again, energy and water that require high reliability. Resiliency will be another word we use there. That it's very important to benchmark the resource performance, then optimize that performance. And then once you've optimized it, to monitor that performance real time, meaning ongoing monitoring of energy and water use real time. It'll be important to establish a strong project or program team for implementing the energy water projects and other optimization projects. And then it's going to be important for protecting and improving the resilience of critical facilities in the face of man-made and natural disasters. Will require ongoing effort that will require vigilance, contingency planning, and training. So we'll go ahead and we'll go to the next slide, please. So there's another Slido poll here, and this is similar to a previous one, but related. So what sector does your organization represent? So we've got a lot of federal, state, and local representatives, higher education or research facilities, industrial and manufacturing, nonprofits, utilities, and then some other. And we'll give it a few more seconds here for this to populate. And it looks like by far the winner is going to be state, local, and federal governments, which is great. Certainly critical facilities fall under government interactions and responsibilities. The next two are sort of a tie: higher education or research facilities at 18%. And again, higher education often has a lot of these different critical facilities, such as laboratories. We'll be hearing about that. Same for research facilities. And energy consultants and energy service companies are the ones who are often responsible for optimizing these critical facilities. Industrial and manufacturing obviously has a lot of critical facilities. And then we have nonprofit others, and then commercial real estate and for-profit in the mix also. So with that, I'd like to go to the next slide. All right, and on this slide, I wanted to introduce my friend and colleague, Dale Sartor from Lawrence Berkeley National Labs, who's an expert in data centers. And Dale's a staff scientist and engineer at LB&L, where he focuses on building efficient technology applications. Dale has a AB in architecture and a master's in business administration. He's a licensed mechanical engineer and a licensed general building contractor. And again, I wanted to remind you to submit questions for Dale on the Slido link shown at the bottom. And with that, I'm going to turn this over to Dale to start presenting on data centers. Thanks, Dale. Your turn.
All right. Thank you, Otto. You can hear me? Yes.
Yes.
All right. Thanks a lot for joining us here. Next slide. Okay, here we go. So as Otto mentioned, most critical facilities are highly energy intensive, and data centers certainly fit that bill. They're about 10 to 100 times more energy intensive than a typical office. Now, server racks now are being designed for up to or even in excess of 30 kilowatts each. That's like a refrigerator size almost. And there's a surging demand for data processing and storage so that the end isn't in sight. Combined, data centers consume about 1.8% of the US's electrical consumption. That's more than most states. And many of us experience power and cooling constraints within our existing data centers. The potential for energy efficiency is great. Typically, we see 20 to 40% savings opportunities with high return on investments available. But with aggressive strategies, we can yield 50% or more, especially when we combine both IT and infrastructure improvements. By implementing energy efficiency, we not only save money and energy, but we can extend the life and capacity of the infrastructure and also increase the resiliency of the data center. Next. So the first step, and I think this was on Otto's list, is benchmarking, installing metering so that we can understand where the power is being used and track it over time. The two pie charts are illustrative of two typical data centers, and one could assuming that everything else is equal, that the data center on the right, where a greater percentage of the power actually makes it to the IT equipment, is more efficient than the data center on the left, where only about half of the power makes it to the IT equipment. This basically describes a metric called PUE, power utilization effectiveness, which is the total power divided by the IT power. And by using such metrics, we can compare our performance to our peers, and there's a wide variation. You can see the graph at the bottom right, where the green or yellow is the one, or the IT load, and the blue is the ratio, or the amount of power that goes to the infrastructure. By looking at the best performing data centers, we can identify best practices, and we can identify opportunities for improvement, and we can track performance over time. Next. So the opportunities are varied. I'll start on the lower right, the supplying the power to the data center. Here we can use renewables or on-site generation for resiliency. We want to deliver that power efficiently, and one example in data centers is high efficiency UPSs. We've seen UPSs consume large percentages of the power just because of their age and how well they're loaded. And then in the IT equipment itself, there's a lot of opportunities. For example, with virtualization, we can dramatically reduce the number of servers required and hence their energy consumption. And then all the energy that goes into a data center eventually has to be removed with cooling. And there's a number of opportunities there, including better air management and the use of free cooling. Next. So DOE is ready to help. The Center of Expertise provides tools, resources, and training. And on the training front, we have a website or URL for coming up webinars. So I welcome you to join. Thank you. I think that's the last slide.
Great. Thank you, Dale. What I'd like to do now is move on to Wendell Brase, who's the Associate Chancellor for Sustainability at University of California, Irvine. And Wendell will be talking about laboratory buildings. Wendell is the first Associate Chancellor for Sustainability. In this role, he leads UC Irvine's sustainability efforts, and he also assists other campuses throughout the University of California system to implement UC's carbon neutral initiative. Wendell also co-chairs the University of California's Global Climate Leadership Council. And again, similar to with Dale, please submit questions through Slido, for Wendell. And with that, Wendell, please take over.
Thank you, Otto. Can you hear me?
Yep, I can hear you. Thanks.
Okay, I'm ready for the first slide. So I'll focus most of my remarks here on smart labs, but let me first start out by talking a little bit about the basics in a smart building, any smart building. I think these 4 attributes here exist in any type of smart building. If you want to call it smart, it needs to have demand-controlled HVAC. Demand-controlled could just be occupancy controlling HVAC, as well as lighting in a simple office building. But in a laboratory building, you'll see that we measure a lot of other things for demand control, like CO2, particulates, VOCs. This is all about precision control. So that means you need quite a few HVAC zones. You can't have one zone be half a floor. You have to have zones that are small enough that you actually get precision control using the kinds of sensors I just described. We found that right-sizing air changes actually results in quite a few benefits, including minimizing reheat, especially in an air conditioning climate like we have. And it's not just about HVAC ventilation and exhaust. It also includes efficient lighting and more efficient plug loads to really make it a holistic idea. Next slide. So, Smart Lab. What I'm going to say now, and in the next couple of minutes, will be very oversimplified. It actually takes a full day packed agenda workshop to cover what we call the Smart Labs program. We call it a program because it's a whole different way of looking at laboratory operations as well as design. If anyone's interested, by the way, in our Smart Labs workshop, we tend to do one every July or February. It's a no-cost event, actually, or a very low-cost event. And if anyone's interested, contact us, and we'll put you on the list for the next one. So the Smart Lab, in terms of its outcomes, the 3 outcomes you see here are the kind of basic ones you find in every Smart Lab. So reducing energy consumption by half. This isn't an aspirational goal. It's actually been measured we've done about 25 of these projects, about 15 in retrofitted existing buildings and about 10 in new buildings. The average for new buildings is that we're beating California's Title 24, which is a tough energy code, by 50 to 55% on all those projects. And then for the retrofitted ones, there it's a before versus after measurement. And our results range from 41% to 80%. We are also improving safety. Again, we have data on this. You'll see why as I describe it a little bit more. And we have a data stream in the background that actually enables sustained precision performance. In other words, we need a system to keep a smart building smart, or a smart campus smart. And that's what that last one's about. Next slide. So here are the fundamental components of a smart lab. The first 2 bullets we've already touched upon. The next 4 bullets about exhaust fan discharge airspeed, pressure drop optimization, fume hood flow optimization. So those 4 are really performance specifications. And we use performance-based specs in our design build competition process for all of our new laboratories that we build, and actually most of the retrofits now, we're using design build competition. So we're a public research university. We share everything openly that we have tried and worked on in a way that we know will be worthy of sharing with others who are working on climate solutions. We think that's part of our mission. Anyone can have our performance specs that represent these bullet points here. Just ask and we'll give them to you. Commissioning with automated, that's about the informatics system that's in the background. It's not just for laboratories, by the way. On our campus now, we have a lot of informatics behind all of our buildings of all types. We're measuring 465,000 data points every 5 seconds at the UC Irvine campus. Next slide, please. This is a simplified cartoon of a demand-controlled ventilation concept here. If you can give it one click, it'll animate this slide. Here we go. You see the vacuum pump down here in the corner near the sensor suite is creating a vacuum. It's drawing an air sample from the outdoors. That's the reference probe. Then it's taking a sample from room 1, lab room 2, classroom 103. It doesn't do it this fast in real time. It does it about every couple minutes because it's for each one of those air packets that's coming down to the sensor suite, it's evaluating all those things: total VOCs, carbon dioxide, carbon monoxide, dew point, particulates down to a pretty low or a very high level of resolution. All that data is ending up at a web-based user interface, which I just mentioned. Next slide, please. This was a really great and welcome surprise to us. We had no idea that the co-benefits of this program would be as massive as they've turned out to be, or as valuable as they've turned out to be. Real-time commissioning and fault detection and making laboratories safer, those are two sides of the same coin. The reason laboratories are safer is because we discover faults, they're detected within minutes or hours at the most. Some of those faults, I think, probably could go on for decades in a university in the old paradigm where we didn't have this kind of informatics. We consider a laboratory a safety machine. A good machine operates with precision, and it has precision fault detection. That's why our laboratories are safer, and we have the data to prove that. Indoor air quality and improved infection control, again, two sides of the same coin. The fact is most pathogens are hitchhikers. They travel on particulates. We've been able, because we've slowed down air changes and therefore the air speeds coming through fans and filtration media about in half. And that means our standard filter is now a Muir 14, which is 1 notch below a HEPA filter. That is a safer infection control environment. The next thing here is longer life, reduced speed. Everything that's turning or heating or cooling is basically running at half speed. And some of those devices follow the square rule, meaning they're going to last not twice as long at half speed, 4 times as long. Some actually follow the cube rule, like exhaust fans on lab buildings. They'll last 8 times as long. We're a public research university. Taxpayers pay for us and tuition payers. This is a big deal, actually, having this kind of savings. Avoided carbon costs. Carbon costs in California are still pretty low. The cap and trade, the last auction was only a little bit north of $15 per metric ton. We expect that number to get much higher. These benefits will accrue for years and years and years. Deferred maintenance, about 10% of our retrofitted projects went into fixing deferred maintenance problems, including things that were unfunded and would have stayed that way if we had not had all the energy savings we yielded through this program, which have now fixed all these deferred maintenance problems in laboratories. And yeah, the maintenance expense, same thing, same story. We can just scan this for a second, and you'll realize we can actually put dollar numbers on a lot of these estimates. These are tangible economic savings. We can add these up, and that makes a project which was already net positive in terms of the cost to benefit ratio. It makes it massively beneficial. It's practically a no-brainer. Next slide. So here's my final summary. We've already talked about the energy savings, safety, no deterioration due to this continuous commissioning using the informatics layer that I've described, lower maintenance costs. I guess I talked about all these things now, but I did actually forget to mention one thing here, and that's just because we take it for granted. All of this adds up to a more reliable research environment. That is priceless to researchers. That's why I enlisted. We just take for granted that is probably the most important benefit for a research university. So that's the end of my remarks. Thank you.
So thank you, Wendell. Those were great remarks. And again, reminder for everyone to go to Slido and submit questions for Wendell or Dale or our next speaker, Jen Muir from JKMuir LCC. Jen will be talking about wastewater facilities and the energy water nexus. A little bit of background on Jen. She's the president of JKMuir LLC. Jen's experience includes conducting energy evaluations of pumping and process systems, design of improvements for those systems, and obtaining grant funding. Jen received her bachelor's and master's degrees from MIT in environmental engineering. She's a registered professional engineer. With that, I'd like to turn it over to Jen, and let's learn about wastewater facilities and energy water nexus. Go ahead, Jen.
Thank you so much. Great, well, let's get started. A pleasure to be here with all of you. And again, what we're going to talk about just in the next few minutes here is about the water energy nexus and how we service this with our critical facilities. So let's just get right to the next slide. So why water? Why are we spending so much time talking about water? Well, I want to just give you a quick overview. I think it's really clear to us why these are critical facilities. And of course, it has a lot to do with the fact that these are essential to public and environmental health. And we also need to do them on a local level. That's obviously how we handle both drinking water and wastewater treatment. But in terms of their energy usage and where we see this water energy nexus come together is that it's over 75 billion kilowatt hours per year in the water industry. That's over 3% of the total US consumption, more than or equal to the entire residential demand of the state of California. And you might be surprised to know that it's actually more than the pulp and paper and petroleum sectors combined. So a huge energy usage and something that we often don't think of, right? We all just walk over to the sink, we turn on the water and the water arrives. When it goes down the drain, it just goes away. And it turns out that this is actually a huge energy sink in our world. So it's about $4 billion a year is spent on energy in this sector. So when I talk about critical infrastructure, I'll just point to this picture that's in the lower right-hand corner of your screen, and you can see this wastewater facility, of course, looking very beautiful, sitting on the edge of the river here. And what I want to point out, though, is that if you think about the most efficient way to transport wastewater in particular, it's, of course, to let it run downhill through our collection system. So what ends up happening, in addition to being very critical to public and environmental health, is the fact that these facilities also sit in very low-lying areas and are going to be subject to the implications associated with sea level rise. Again, why water? We see these facilities increasing their energy usage so that they can meet more stringent demands in terms of regulations. This is both on the drinking water side and the wastewater side. We've got leaks and losses in these systems. When we think about the status or the state of our infrastructure in this country, we know all of our public infrastructure is lacking in some ways, and in particular, our water wastewater infrastructure is aging. So we've got leaks and losses, and we also have the large cost that's associated with upgrading these facilities. I'm going to talk about pumping in a minute, and we can just go to the next slide. So let's talk about pumping. One of my favorite quotes when I talk about energy efficiency in the water sector is to say that if we want to avoid extreme energy, we need extreme efficiency. And I really think the water sector, and in particular drinking water and wastewater facilities, provide this opportunity to really mine past the low-hanging fruit and get down to how do we get to some really substantial efficiency. And what it means is that we have to think about pumping. When you consider your water sources and where your wastewater goes, think about how many times every individual drop of water is pumped as it comes out of a reservoir or a well, through a treatment facility, a booster pump out to you, and then again down through the sewer system, pump stations, and a wastewater facility. This is how much energy we're using for pumping. Electric motors in North America account for 66% of the industrial electrical usage, and of that, 25% is from pumping systems. In a typical municipal water system, we're talking about energy usage associated with pumping systems of about 46%, or about half. And most importantly, for the end user, the overall life cycle, the amount of money they're going to spend on that pump from the time they buy it through its entire life to replacement, energy costs represent about 75% of that. So again, pumping being very critical and an excellent opportunity for energy efficiency. Next slide. So I want to just talk about some of the touch on some of these unique opportunities we also have for renewable energy in this sector, and particularly at the wastewater facilities. This is the DC Water wastewater treatment facility. Many of you may be familiar with it because it is one of the largest ones in the country. But what's interesting about the water sector is that we didn't used to hang out with the solid waste folks, but now because of our push towards sustainability, we see that many municipalities are trying to go with zero waste. What does that mean? We've got to get the waste out of the landfills. One of the most important components is organics. Well, it turns out we're already dealing with a lot of organics at wastewater facilities. And by combining both food waste and wastewater, so joining these two sectors, we have an opportunity to produce basically a renewable fuel or renewable gas through our digestion process. So just an example of a city that's considering this and embarking on this. Next slide. Similarly, an often overlooked aspect of what we can regain or recapture from what we've traditionally called a wastewater, is the fact that it has this latent heat. It's the idea that it's actually warmer than the air and that we can actually mine that heat from it. And just an example of Vancouver setting up an actual large-scale facility to do this, in which they're actually taking out or utilizing the heat from the sewage, and it's supplying a substantial portion of the hot water needs in that area, heating and hot water needs. And next one. And again, just another example of major cities really looking at how they can minimize the energy impact, the energy footprint of their water and wastewater facilities, is to really try to combine how do we mine out all of the energy potential of the wastewater itself. So again, through solar, thermal, and then what we called cogeneration, and in some cases co-digestion with the food waste. But in this case, I like to point out that not only has the Philadelphia's wastewater facilities looked at solar, substantially looked at some of the energy efficiency opportunities, but they have also taken things like aircraft de-icer from the airport, and it will actually be useful in producing additional biogas at this facility, which further offsets their own energy footprint. So we see a strong move in the water wastewater industry to move towards what we call energy neutrality or net zero. Happy to answer more questions about that. And again, pleasure to be with you. Thanks so much.
All right, thank you, Jen. That was a great presentation. And again, reminder for everybody to answer or to ask questions on Slido for all our speakers and our next speaker coming up, which is Dan Mastin from New York-Presbyterian Hospitals. Dan is the Energy and Commissioning Program Manager at Presbyterian, which encompasses 9 hospital campuses covering 8.6 million square feet. Dan holds a certified energy manager and certified measurement and verification professional certification. And with that, I'd like to turn this over to Dan and have him tell us about hospitals. Please take over, Dan.
Good afternoon. Thanks, Otto, and thanks, RETEC and the Department of Energy for inviting me to join the panel today. So this slide kind of shows a brief overview of New York-Presbyterian's infrastructure portfolio, some background on NYP. We're proud to be named the top 5 hospital by U.S. News and World Report in our most recent ranking. Kind of unique. We're the teaching hospital for 2 Ivy League institutions, Cornell University and Columbia University. Another unique thing about New York-Presbyterian is that our 2 largest campuses act as district utilities for some neighboring institutions, hospitals, residential and commercial buildings. Next slide, please. In the commercial building sector, hospitals consume an outsized proportion of energy compared to their footprint. According to EPA, the EUI of a medium hospital is about 2.5 times that of a median commercial office building. There's a wide variety of hospital types. They're not all created equal. For instance, there's difference between a specialty hospital like a bone and joint center where you might go and get a hip replacement versus a large academic research institution like New York-Presbyterian. Another example is New York-Presbyterian has about 400 intensive care beds. If Presbyterian itself were a state, we'd have as many ICU beds, about as many as the entire state of New Mexico. There'd be more ICU beds than 12 other states in the country. ICUs have strict conditioning and pressurization requirements. More ICUs typically leads to higher energy consumption. So you can see how different programming at different hospitals would affect energy consumption. Next slide, please. There's a lot of challenges to energy efficiency in the healthcare sector. We have a wide variety of ages of buildings. There's been huge changes of building codes over the last 100 years. Working in older buildings can increase project cost and scope as we need to bring different systems up to current code. Hospitals are subject to numerous regulatory bodies beyond just the local code authorities. We have Joint Commission, which provides certification for and accreditation for Medicare and Medicaid funding, which makes up a lot of hospitals' revenue. Regulations and interpretations between all these different regulatory bodies can be contradictory. That increases the complexity of our projects. Next slide, please. Within the last 10 years, New York City has implemented and adopted a number of regulations dealing directly with energy efficiency. Many of these are being adopted by other jurisdictions throughout the country. Implementing each of these regulations poses unique challenges to hospitals. Most of them are sort of focused, I think, more towards the commercial sector. Hospitals need to still meet these regulations, but you know, the application and the cost-benefit analysis for hospitals is a whole different calculation, and sometimes the savings and the paybacks aren't as great for hospitals as they are in the commercial sector. Next slide, please. The most recent and challenging regulation that has been put forth by the city is Local Law 97. This sets carbon caps on buildings based on the occupancy type. Hospital is an I2 occupancy. Here are the carbon caps for hospitals, and they get more stringent as the years go on. About every 5 to 6 years, the carbon cap on a building is going to be reduced. Emissions for each building are going to be calculated based on your energy consumption, your electric, natural gas usage, district steam, fuel oil, and applying those carbon coefficients that you see in the chart there on the slide. If your emissions exceed the cap, you're going to be fined at a rate of $268 per ton. The fines are, you know, starting especially in 2030, are expected to be pretty significant. By 2030, hospitals in New York City will have to reduce their EUI by roughly 2.5 times or face significant fines. A reduction of this magnitude would put hospitals, EUI of hospitals on par with a median office building. So it's a really significant reduction. You know, the question I pose is CO2 per square foot a good measure of efficiency? You know, are there better metrics out there? New York City in general has a low carbon per capita carbon emissions compared to suburban areas, as you can see from the maps there. You know, New York City, Philadelphia, Baltimore, Washington, D.C., Richmond, they really stand out as being, you know, low carbon emitters per capita because of the high density. Next slide, please. You know, some of the challenges of energy efficiency in hospitals, completing projects. We're occupied 24 hours a day, 7 days a week. Typically, we're operating at 90% plus occupancy. You know, changing lights, for example, isn't as easy as it is in an office building. We can't just go in at 5 o'clock, change a bunch of fixtures, and then nobody's there. You know, we have people there all the time, and we have infection control protocols that we need to meet. In that picture there You can see one of our electricians is working in a HEPA cart. Anytime we get up above the ceiling, we pull a ceiling tile, we need to have one of those carts available. So it's negatively pressurized. It captures all the dust and prevents it from getting into patient spaces. You know, a lot of the patients are immunocompromised, so this is a method of protecting them. It increases the cost, time, and complexity of completing projects. So doing something like a lighting project, you know, this increases the payback of that project. We also have operational requirements, temperature and humidity requirements that, you know, might prevent us from being as aggressive with certain set points, you know, chilled water resets. We can't economize necessarily as aggressively as some other building types. So that's a challenge as far as getting more efficient. Next slide, please. So here's another example. You know, we're replacing air handlers in critical areas. When we're doing this, we need to find another way to supply air to the space. So this might mean providing, installing temporary ducting from another air handler to serve the space for temporarily. We might also have to install a temporary air handler. We have a project right now where we had to crane lift a 25,000 CFM air handler to the roof temporarily while we replace 2 air handlers serving an OR. This is going to serve as a swing air handler. At the end of the project, we'll remove the temporary air handler from the roof. Again, it requires two crane picks, you know, significantly as the complexity of the project and also the cost. Another way to do it, and what you see pictured here, is we can demolish and replace one section of an air handler at a time over the course of 3 weekends. So Friday, the space gets shut down. We demolish one section of the air handler, replace it. We start it up as a Frankenstein unit, operate it for the week. The next week, we might demolish the coils, replace that section, start it back up, operate again, a mix of the old and new unit for the next week. Third weekend, we replace the mixed air section, demolish it, and then we have a brand new unit. But, you know, we're running around the clock with demolition and construction from Friday evening till Monday morning to get it back in operation for the Monday through Friday work week. And, you know, paying premium time, it's costly to do a project like that. Next slide, please. So all these challenges increase the cost and complexity of you know, completing these projects. It doesn't necessarily increase, the energy savings don't increase, so that what it does is it just pushes the payback of the project out further. State and utility incentives, at least in New York, seem to be more set up for a typical commercial office building. They don't, you know, really offset enough of the project cost to move the needle to make the projects that much more attractive. So we need to look to other areas to show value with the project. This could include, you know, reductions in operations and maintenance costs, and increased resiliency, reducing liability, increasing the lifespan of assets. And we can stack those values. It makes us easier to push these projects forward and get them funded and implement them. Next slide, please. One of these projects that, you know, we were able to stack multiple values is we're currently in the process of winterizing a couple of our cooling towers. Right now, anytime the temperatures drop below freezing outdoors, we have to drain the cooling towers below the roof line and shut down the central chiller plant. This requires that we have multiple process chillers for imaging equipment and pharmacies and, you know, other critical areas throughout the campus. So we have tons of process cooling all over the place. It's not on the central plant. Once we winterize our cooling towers, we'll be able to operate the central plant year round. We can eliminate some of these process chillers. We don't need to drain and refill our cooling towers, you know, multiple times every winter, which is going to save on overtime. It's going to save on our water consumption, our chemical consumption, and water treatment. It reduces the number of times we need to sterilize the tower. If we have to sterilize the tower, we kind of open ourselves up to potential fines from the city if we do it incorrectly. Installing a water side economizer is going to allow us to reduce our air side economizing, which is going to reduce our humidification loads. So there's a lot of different values beyond energy savings that we're able to stack into this project, and it makes for a great, a good project for us financially. And I think that's it. So thank you.
All right. Well, thank you, Dan. That was a great presentation on hospitals and very challenging sector, and look forward to lots of questions that hopefully the audience is submitting through Slido. In the meantime, I'd like to move on to our next speaker, Chris Halpin of NV5 Energy Efficiency Services. Since 2003, Chris has been a FEMP-approved project facilitator, where he has managed over $2 billion in projects for federal agencies. Impressive number. He is currently working on public-private partnership energy projects and resilience/microgrid projects for several clients. In 2018, his firm Celtic Energy was acquired by NV5 Global, a large multidisciplinary engineering and technical services firm. And with that, Chris, please take over and tell us about high security facilities and some other things.
All right, Otto, thank you so much. Appreciate it. And everyone here on the panel, thank you for your time, and everyone in the audience. We really appreciate it. Taking the time out of your day to listen to this webinar. Hopefully you get something out of it. So I wanted to talk a little about high security facilities. And you've heard so many wonderful and interesting things so far from the other panelists. Really some amazing statistics. I was sort of counting up on the back of the envelope the energy use from all these different critical facility sectors that you heard already. And that's between 5 and 10% of the whole American energy use, just in those sectors. So that's a really big deal. So these are some examples you can see on the slides that are up now of facilities that we've actually worked in and helped them with efficiency projects and or resilience projects. And they're all critical in one way or another. We did a comprehensive energy audit of the whole FBI Academy and Lab complex in Quantico, Virginia. That's the lab that everybody sees in the CSI shows all the time, right? It's very famous, very interesting facility. And they pursued some pretty aggressive energy efficiency upgrades. As a result of our study, they did a complete retrocommissioning of that laboratory and saved them a ton of money. And it's a big deal. It's a very big deal for their facilities. And then Jen talked a lot about sanitation and water and how much energy they use and how critical they are. We're working on a project now for LA County Sanitation District where they had some 30-plus-year-old equipment that they needed to have replaced. They didn't have the bandwidth to do it, so they looked outside to bring in a third-party solutions provider that used energy savings as a way to retrofit a lot of critical blowers, compressors, and so on. Same thing with University Medical Center, and Dan did a great job talking about Presbyterian in New York. We were involved in a similar project here in Las Vegas at University Medical Center where they used a turnkey retrofit energy provider to do a bunch of lighting retrofits and other things, but most importantly, replaced air handling units in ORs and ERs without shutting them down, which is no small feat, all paid for out of savings. And then lastly, an example in the commercial sector, we've been working with Pratt & Whitney for about 10, 12 years. They produce all kinds of jet engines, but are the sole producer for the new Joint Strike Fighter military jet engine. And they did the same thing, comprehensive energy audit of the whole 2 million square foot campus in Middletown, Connecticut, one of the most secure facilities I've ever been in. And we're able to identify tons of energy savings that they could fund internally and also go outside if they wanted to. Now, what all of these facilities have in common are high security, the absolute need for continuity of operations, in general, a lack of funding for operations and maintenance, which is surprising for some of the premier level things that you see here. But I've seen this in Fortune 50 companies. And deferred maintenance, big issue, is becoming a crisis level now in many sectors. And a reduced availability of capital, especially today, whether you're a federal, state, local government agency, hospital, private company. Just because of COVID-19 alone, there's serious issues with trying to get capital. So opportunities that present, exploring alternative approaches to funding solutions to common challenges. And you've heard this all already. There's tons of challenges, lots of opportunity. Next slide. So sort of a tagline here is critical facilities, so much to do, so little funding. And it's very true. So how do you get past this? Well, if you're in the federal government, one of the things you can do is, try to get whatever budgeted funding you can find. Sometimes some of our clients go after end of year money. If things haven't been spent in the budget by July or August, they can sometimes get money towards the end of the fiscal year, which is September 30. And at least use that as a seed fund to attract more capital to your project. You can also look at alternative finance projects, and you'll see that all of these are live links, which we don't have time to get into now, but you can take a look at yourself afterwards. Some of these projects include energy savings performance contracting, which the federal government has done over $8 billion worth in over 750 projects around the country and overseas. Utility energy services contracts, where you do a similar turnkey retrofit project, but you source it through your local utility through an area-wide agreement. So you don't need to go through the whole elaborate federal design, bid, build, procurement process. You can do an enhanced use lease, which is less commonplace, but it's commonly used for sort of military bases will basically hand over a chunk of land that they're not using to a solar developer who will put a large solar array and give the government right of first refusal on use of that electricity. So the government gets a benefit. And one of the more interesting ones that have come up here in the past few years is energy as a service and resilience as a service. And this is something that's becoming really critical, as we know. You've heard it all already, how important keeping these facilities operating are, and not always having the funding to do it. And that's a link to an NREL study that describes in fantastic detail how you can really take a look at resilience as a service for your facility. And I want to close this slide with a great quote from Mark Carell, who's the colonel in charge of the U.S. Air Force's Office of Energy Assurance. And everything in the federal government today, and I'm seeing it bleed down into other levels of the government, is mission assurance through energy assurance. Next slide. So same thing in federal government. You can talk to your federal project executive, find out what resources are available, talk to them and your contracting officer. You need to get contracting officers involved from the very beginning of any kind of project you want to do. Start the acquisition process, develop and implement the program. And again, I do a full day class. I know it's hard to do it in a few minutes. Enjoy benefits of avoiding the business interruption. This has been a big deal for a lot of clients, and repay the financing for the term of that contract. So you don't have to wait for capital appropriations. You can use third-party financing for this. Next. For state and local governments, it's very, very similar. You face a lot of similar challenges. You can use an organization called the American Society of Hospital Engineers if you're in hospitals like Dan and others are, any kind of healthcare facility, where they have best practices in business planning for energy resilience. Contact your state energy office or the National Association of State Energy Officials about their programs. They've all got assistance in this realm for you. Also, what most people don't know, everyone knows FEMA after a hurricane or a tornado, they come and help people, rebuild homes and so on. But they also have a pre-disaster mitigation grant program, so you can basically help things like this fire house be more resilient. So in case of a disaster, they're prepared. They have solar with battery storage, say. We've seen a lot out here in the West to help keep these programs running. And the USDA also has a Rural Development Energy Program, a fantastic grant program if you're out in the country. You can also consider performance contracting if you're a state or local government agency. The Energy Services Coalition has tons of resources for you. And always contact your local utilities about incentives and grants. You can get 30 to 50% of your project paid for through these incentives and grants. Next. So for private entities, again, have a lot of the same challenges, but they've got to turn a profit on top of providing a service. So a similar process, except you don't really have the opportunity to do these long 20-year performance contracts and UESCs. But what you do have in many states are commercial property assessed clean energy programs. And again, that's a live link to PACE Nation, which allows any commercial entity that pays taxes to a local government to basically fund these projects through their property taxes, pay for it over 20 years. So you can take a 7 or 8 year simple payback project, pay for it over 20 years, and it becomes a huge cash outlay for the site, actually a cash producer for the site. And the investment stays with the property, not the owner. So the owner can sell the building 2 or 3 years later, and the new owner takes over that assessment. It becomes a special assessment like a sidewalk or a sewer assessment. and also conduct research about investments or grants, and on-bill financing is a big opportunity for many, many businesses. Next. That's all I have. Thank you again so much. Appreciate it.
Well, thanks, Chris, for that great presentation. And now we're going to move on to the fun part, the main part of today's session, and that's the panel discussions. So as a reminder, do go to Slido and submit questions. And with that, we're going to go ahead and move to the next slide. And again, our panel will be broken into 2 rounds. Round 1 will be themed Q&A. We'll start with continuity of operations on that one. Then we'll have project implementation and energy management best practices. And then in round 2, we'll have the remaining questions from Slido. So next slide. And for practice on Slido, for continuity of operations on a scale of 1 to 5, rate your building's ability to continue essential operations during disruption, meaning like a grid outage, severe weather event, cybersecurity attack, those sorts of things. And from this, it looks like the majority, this is a pretty nice distribution actually. Yeah. The majority is moderately prepared, 3 out of 5. And then about a quarter, so that's about 40%. And then about a quarter is 2 out of 5, and a quarter is 4 out of 5. And then there's some outliers. There's some outliers who are 5 out of 5, about 10%, who are ready for anything. And that's awesome. I'd like to hear how you're doing that. And then there's another, say 4%, who are in trouble. They are going to have some challenges here. And having some good responses. I'll give it a few more seconds here. I don't have quite as high responses we had before, something like 77 people out of our remaining 400 on the webinar. And it looks like that distribution is going to be the final answer. So with that, let's go ahead and we're going to move to the panel view. And from this view, which you'll see for the remainder of the presentation, I'm going to ask questions that I've received from Slido, and I'll direct them to certain people on the panel. Make sure all the panel members are unmuted here. And I'm going to go ahead and start with a question for Wendell. Then I'd like to have Dan and then Dale comment on this one, but starting with Wendell. How do you balance the need for reliable power for mission critical facilities like labs in your case, or hospitals for Dan, or data centers for Dale, with the desire for efficiency and sustainability? So Wendell, if you could start us, and again, then Dan, and then Dale on that question.
Well, a research university has a lot of facilities which need continuity of power. It's not just that we, many of us have hospitals, but we have a lot of outpatient facilities which are not on uninterruptible power. We have animal colonies at every research university. I can tell you right now there are animal colonies for researchers who are working on, if not vaccines, therapeutics around the COVID pandemic. There are advanced microscopy centers, which actually, a lot of people don't know this, but they don't take a quick photograph of a specimen. They run sometimes for days, actually. Growth chambers, all these ultra low freezers you see in research universities, those are full of research specimens that will be lost, and their value, in fact, will be lost. And the value is not just economic value, it's all the high-priced labor that went into those experiments that are represented. So this is a really big deal for universities. And having a university which has the kind of informatics that I talked about a few minutes ago really makes it possible to do a holistic solution. This is just the opposite of having battery backups in stairwells and corridors, space by space. This is looking at it at an enterprise level. And I think universities and medical centers are pretty good at this, actually. Cogeneration is a big asset for those institutions that have it. I was the administrative vice chancellor at UC Santa Cruz in 1989 when the Loma Prieta earthquake interrupted power for the campus. Well, the campus has a cogen, and it went uninterrupted during that major outage. That's a pretty good model of how cogeneration can really make a big impact on resiliency. Now, it's also a very efficient form of energy for a campus. The Achilles heel, though, is that it's carbon-based. It's using natural gas. Fortunately, in Southern California, SoCalGas has made a commitment to decarbonize their entire system by 2045. They have an aspiration to be the greenest gas utility in the world, and they're taking action and scaling up demonstration projects. In fact, some of their work is being done actually in your shop, Otto. They have some contracts with NREL that we know about to scale up the technologies that will need to comprise a decarbonized system. So that would be the best of all worlds for us. If we can transition to decarbonized gas that they think will be done through a combination of not just one thing, four things: hydrogen injection, hydrogen direct service to some things like the ports where you can use hydrogen directly for fuel cells for transport and heavy machinery. Landfill gas, which is just being flared now, harvesting that. Egg-based projects in California, quite a few of them, where using anaerobic digestion for animal waste is in the cards. And then biodigestion for just the waste stream that's coming through normal refuse disposal. So we're hopeful that they will make progress. We know that some of the demonstration projects will be at the University of California, including this campus. And by, again, summing it up, in a university that takes a holistic view of resiliency and efficiency and decarbonization, that's where you get the kind of scale of solutions that we need to really combat this climate crisis that is probably just around the corner.
Great. That's an excellent answer, Wendell. Very detailed. And then Dan, your turn to answer that same question. So balancing resilience or reliability with efficiency and sustainability for hospitals.
Sure. Yeah, resilient power is critical to, very critical to hospitals. The Joint Commission, which is an accreditation agency for the hospitals, requires that we maintain a 96-hour emergency plan with contingencies for things like blackouts. We have currently 25.8 megawatts of emergency power generators to sustain us if we lose grid power. We have a 7.5 meg cogen system on our Cornell campus. I don't think resiliency and sustainability are necessarily mutually exclusive. New York State's got one of the cleanest grids in the country, but I think our cogen system, last time I looked into it, is still more efficient than, the marginal peak producers at this point. And in the wintertime, a lot of the power plants are interruptible gas, so they go to start burning fuel oil, during the coldest days of winter. When they're doing that, our cogen is certainly more or less carbon intensive than those oil generators. Some of the things that I worry about is New York State has some really aggressive goals for renewable energy, 70% by 2050 going to renewables. Currently, I think with nukes and wind, we're about 60% carbon neutral. You look at a state like Texas, where they went to, I think they're about 20% wind generation. Last year in August, temperature spiked to about 100 degrees. Spot electric prices went to $9,000 a megawatt. If you're not hedged against that, your budget went up in smoke. But they were also they had about 3% of excess capacity on the grid. So they're pushing pretty close to the blacking out. As New York goes to more and more renewables, our peak demand is probably going to shift from the summer to the winter. You're probably going to be looking at the grid peaking, sometime 7 a.m. on the coldest days of winter as, New York City especially is pushing to electrify and decarbonize all heating fuels in buildings. So when you do that, the hospital is probably going to need about 40 megs of additional electric supply. So, there's concerns there, and then we have to figure out, how do we back that up? We're looking into some microgrid solutions with fuel cells and, hopefully decarbonizing the gas supply. As Wendell said, fuel cells can operate on hydrogen. So, maybe you can build out your renewables so that, you can overgenerate and create, crack water and create hydrogen and use that to power fuel cells when your solar and wind and other renewables aren't producing.
Cool.
So
yeah, that's a great answer. I'm gonna actually move to the next question. So Dale, you don't get to answer that first one, but you'll have plenty of opportunities for other questions since Wendell and Dan did such a great job. So this next question I'm going to direct to Jen and then have other panelists comment afterwards. But has the current pandemic made you think differently about continuity of operation plans? And then this will be the last question of this session. But again, Jen, if you could start that and then other panelists chime in.
Yeah, what's I think most interesting about that question is just thinking back about the fact that if we think about drinking water and wastewater facilities, that they are in fact critical facilities related to public health. And so we do need to keep them operational. And one of the largest concerns that happened with the pandemic or with COVID was actually the risk to the staff, and that the operation of the facility would be compromised by the fact that we would not have adequate staffing at the facilities. And that was one of the largest concerns for our industry, was how do we protect, not just focus on the facilities, but these critical folks who are operating the facilities, who have that knowledge of how to operate and run these facilities.
Cool. Let's see, others, has COVID affected your view of continuity of operations? Anybody else want to take that one? Dan, yeah, that New York-Presbyterian, you guys were at the epicenter of a lot of this. I'll bet you have a lot of great answers to this.
Yeah, a struggle for all New York City hospitals. We were challenged by the governor to double our capacity. We had to double the number of beds we had. We went from about 400 ICU beds to over 800. It put us, on par with the state of Oregon for a number of ICU beds within our institution. Around the city, field hospitals were popping up. We're putting hospital occupancies in areas that aren't designed to be hospitals, cafeterias, conference room, offices, lobbies. Our friends at Mount Sinai up the street, they put a field hospital up in Central Park, a couple of tents there. The Javits Center, the state set up a temporary field hospital there. It's definitely a challenge when, you have that huge surge. And talking to utilities, for instance, New York Power Authority, Con Edison, to Jen's point, they had people actually moving into the plants and staying there for months at a time, living on cots, and it was to, keep them isolated and prevent them from getting sick, so that the electric grid can stay up and running. Interesting time.
Boy, I guess challenging time.
Yeah.
Wow. Yeah, great job. So with that, I'd actually like to move to our our next questions in round one, and that's on project implementation. I guess actually, maybe we're going to have a poll question. We already did that. So let's go to project implementation. In 1 or 2 words, state your organization's main barriers for implementing projects. So this is a Slido question, and please go there and submit your answers to that. Funding's the most common one. So how about some answers besides funding? Everybody has the funding challenge. So let's see, management buy-in, looks like it's there, red tape, staffing, split incentives between management and C-suite. That's a really common one. That might be a good future question. Downtime, we heard several panelists talk about downtime. Looks like the main themes are funding, no surprise there. That's the normal main theme. Then management buy-in, and then staffing / leadership, and then maybe staffing constraints. But with a lot of other great challenges there also. I'll give everybody a few more seconds to address this one. Again, manpower, staffing seem to come up a lot. My favorite one here is need Otto on our staff. I'm not so sure about that, but thank you. So with that, I think we're going to go ahead and go back to our panel discussion. Welcome back, panel. And in this section, we're going to talk about project implementation. And now Dale is going to have his chance to talk since I cut him off last time. And then the question for Dale is, given data centers are so energy intensive, are there any requirements being put out there, being put out on computer vendors, et cetera, to use less energy? So what are vendors doing? And you can expand that as much as you want to use less energy, Dale.
Sure. And in the PUE calculation I mentioned, I mean, the IT equipment is the one, and that's often the dominant load. The first step, of course, is to buy Energy Star products, Energy Star labels, servers, UPSs, and network equipment. Fortunately, partially because of Moore's law, the efficiency of IT equipment doubles about every 2 years. So, we're doing the same amount of computations now for about the same amount of energy, but I'm sorry, we're doing an order of magnitude more computations now than with the same amount of energy that we did just a few years ago. But I think the key on the IT side is utilization and virtualization, and that's more in the wheelhouse of the users to take advantage. I mean, buying a brand new, super powerful, but very efficient server and running it. I mean, maybe you unload a server that was 10% or 20% utilized, and now you put that same load on a brand new server. Now it's only going to be like 2% utilized, and it's using the same amount of power. So what we want to do is we want to increase that utilization rate, generally with virtualization. And if we can raise that up, we can get a lot more output for the same amount of input.
Excellent. Thanks. That's impressive results and good opportunities. So the next question, this is going to be directed to Wendell to start and then other panelists to chime in. But what are your recommendations, Wendell, for pitching a program like Smart Labs or other optimizing research at other facilities for other panelists to organizational leadership? And can you address justifications providing upfront capital for projects, maybe even how you funded some of your projects? So Wendell to start and then other panelists.
Well, we funded the Smart Labs improvements in buildings in 2 ways, depending on whether it was a retrofitted building or a new one. So for retrofits, what we did was the University of California, for all of its campuses, issued revenue bonds, 15-year revenue bonds. There is some logic to the 15 years. The logic is, this all started when the University of California in late 2007 made the commitment to become carbon neutral. The entire University of California, 10 campuses and 5 medical centers. And we didn't know how we were going to do it, frankly. We knew that the first big bite out of the carbon footprint would be deep energy efficiency, going deeper than we ever had, questioning all premises about things that were called best practices and standard practices, challenging those things. And wow, did that work? I mean, Smart Labs is a prime example of how deep that went. So those projects, the first Smart Lab projects are paid for with 15-year debt. And see what happens with that debt is it's paid off in 2024. The first debt issue was in 2009. It was 15-year debt. 2025 is the day that the University of California has made the commitment to become carbon neutral. We expect to pay more for decarbonized energy. We think it's a big fallacy to just look at the cost of solar panels going down and say, oh, renewable energy is going to cost less than carbon-based energy. That is an oversimplified answer. It's ridiculous because it takes not into account at all the huge investments that are going to have to be made in storage, including seasonal storage, the grid improvements, all the resiliency stuff that is in the background at the infrastructure capital level. So we think we're going to have to pay more for decarbonized energy, and deep energy efficiency improvements will be paid off at just the right time to do that. So that is the logic behind that. I think I've drifted a little bit from the intent of your question though.
Yeah, and maybe the second half is management buy-in.
Oh,
for
management.
doing all those cool things.
These projects actually paid off. That was before we knew what the co-benefits would be worth. So if you take that list of co-benefits that I had on that slide and put actual economic estimates on things like longer life of equipment and less capital having to be spent in the central plant, and then it's really hard to put a dollar number on safer laboratories. They are safer. We have fewer airborne exposures, and that's what ventilation and air changes in laboratories are all about, is preventing airborne exposure, illnesses and injuries. Way less. It's hard to put a value on that because that's human suffering. And it's not just lost time, it's human suffering. And so what you get is just an overwhelming ratio between the benefits and the costs, and management bought that. And actually my boss at the time when we started that program, Michael Drake, he's a physician. He's now the president of the Ohio State University. And as soon as he saw that the students in laboratories and researchers in laboratories are going to be safer, that really sold it.
All right. So we're going to make that the last question for that subsection and move on to the energy management best practices session because we're going to run out of time. The first question will go to, let's go with Jen on this one, and then Chris. How do you see the first one is Jen. How do you see the future of anaerobic digestion playing a key role in renewable energy investments as electrification becomes more appealing? So real specific anaerobic digestion question.
Yeah, great question. So it is a really important technology, particularly in the wastewater industry. And it does provide some ancillary benefits because at the same time we're doing anaerobic digestion to produce biogas from the sewage sludge, we are also reducing the volume of waste product that eventually has to be disposed of or hopefully beneficially reused, which is what we optimally like to do with the sludge or the biosolids. But as I noted in the slides earlier, was that in addition to that, we have some of this drive for zero waste or organic source separation. And so our need to find a way to utilize that waste product as well really encourages the use of anaerobic digestion. But to answer the portion of the question about electrification, we really have two choices in terms of what we do with the biogas that's produced. We can do cogeneration on site where we're actually producing power on site as well as heat. And that can be, that's usually the first choice of a facility that has anaerobic digestion. And I think will continue to be that way for a long time because they have such a large power demand on site that they need to offset. The ability to make their own power on site provides both resiliency, reliability, in addition to the obvious cost savings associated with energy reduction. But we do have another choice where we can clean up the gas to the level so that it can be used in a CNG fueling station or we can direct inject into the natural gas pipelines. And of course, there's some incentive programs and credits that can really make that a very viable and cost-effective option. And so my recent discussions with folks is that may be a way to go in the short term, a bridge type of technology. But I do feel like that anaerobic digestion is going to be with us for a long time because of its usefulness in breaking down organics.
Great. Well, thanks for that great answer, Jen. And the last question will be for Chris. Are there differences in O&M strategies for high security facilities compared to normal facilities, say an office building? So how do you do O&M for high security facilities?
Sure, thanks. Great question. So there's certainly a big difference, and depending on the level of security you're talking about, the difference between going into, say, a city hall versus a maximum security prison or an FBI facility. There's a big difference in level of O&M that's required. What often happens is the background check process and vetting process of the employees of the companies or the agencies that are running those facilities, as well as all of the contractors that they bring in, are probably the first line of defense. That ends up cutting down the pool of applicants you can have either working for you directly as an employee or as a contractor. So it requires a lot more time and effort, honestly, to get either just normal daily work done, if you're an employee, to just operate air conditioning equipment, heating equipment, process equipment, all that. On top of, if you have to bring people in to do this work on a major retrofit project, like say you're going to do an anaerobic digester at a wastewater treatment plant, you're going to be replacing a bunch of air conditioning unit like Dan was talking about at York-Presbyterian. It takes a long time to get set up, to do the work, to clean up and leave and get off the premises, right? And it ends up taking more calendar time, as well as more costs. And this is everything from just regular operations and maintenance, even just changing filters in an operating hospital. I've been involved in hospitals for 35 years, and it's incredible what these folks are able to do to get that done, because if you have to run 24/7, it requires a very strategic level of planning to be able to do that. One of the things we're starting to see is a sort of combination of HVAC technologies and IT technologies, the whole Internet of Things offering that's going on, and using sort of the power of data to optimize when you really need to get in to those pieces of equipment and change filters, lube motors, reshift fans and all that. Because before it would be like, every 6 months or every 4,000 hours, you're going to do this. Now we're finding, using real-time data acquisition, you only need to do it when absolutely necessary. So you may change 1 of 10 filters that you would normally have changed. So that saves time, saves money, saves expense, and ultimately it helps the bottom line, whether you're a public agency or a private company, which is important to everybody today. And you can then gauge the energy efficiency of these things using building analytics in combination with computerized maintenance management systems. So there's a lot of powerful tools out there you can use.
Great. Yeah, and that's a great tie into some of the things Wendell talked about building analytics in the information layer.
Mm-hmm.
So we are almost out of time, and I'm going to first thank all of our panelists for this great discussion. We have a lot more questions than we're going to have time to get to, but offline we'll try to answer some of those. And with that, Izzy, do you want to switch to some wrap-ups and some additional resources? Hopefully you guys, everybody listening in, was inspired by what you heard from our panelists. Here's a list of additional resources. When you get the presentation, this is all be live links, so I won't read through all of these for you. Maybe if you could go to the next slide, Izzy, on the Building Solution Center. Again, this is a comprehensive suite of available resources. over 2,800 solutions to help you find proven and cost-effective energy and water solutions. Then there is also a video, which we're not going to play right now, talking about the Solution Center. And then the next slide. There's also a Better Building Summer webinar series. Again, you can click on the register now to attend these great webinars. I'd encourage you to attend all of these. Let's go ahead and we'll go to the final slide. And for additional questions, you can contact any of us. All of our presenters are listed on the right-hand side, and through Twitter or the Better Building Solution Center, you can contact us at those locations. I'd like to thank everyone for submitting all your questions. Sorry we couldn't get to all of them. And I hope this was a valuable session, and hope it was, more importantly, valuable for you, and you'll go out and implement some of these solutions for your critical facilities. With that, I'd like to go ahead and end this webinar.